next part or third part of a problem. Now find out the end moment. Let's say MAB is equal to M1AB plus CM second AB. Now what is this MAB first and MAB second? So MAB first means it is calculated by considering frame as a non-sway, and MAB second means it is calculated by considering frame as a sway frame, and there is applying the correction factor for the sway moment. Okay, so end moment is nothing but the moment calculated by considering frame as a non-sway frame. This one is the first moment, and the second moment is a moment by considering frame as a sway frame, and there we apply the correction C. So this C stand for the correction which we apply for the sway moment. Okay, so by considering that we will get end moment for the column AB and column CD, where here we mention where the C is a correction factor to be obtained from the shear equilibrium equation. Now let's consider column AB FBD and consider anti-clockwise moment positive, clockwise moment negative. Now consider here at B there is a assumed let anti-clockwise moment MBA, and for column AB A end consider the end moment MAB as anti-clockwise. Now assume there is a shear force HA toward the right hand side. This is our assumption. Now take moment about B. So moment about B is equal to 0. There is also shear force, but it will be going to be 0. So there is no need to consider it. There is a shear force at B. So there is also 2 kN point load acting on the column. So taking moment about B, we have HA into 4. HA is a force and lever arm is 4. It is rotate about B point in anti-clockwise sense. That's why positive HA into 4. Now moment AB plus moment BA anti-clockwise, so sign is positive. And next is 2 kN force rotate about B in an anti-clockwise sense, so their moment is 2 into 3 is equal to 0. So we have HA is equal to minus in bracket MAB plus MBA divided by 4 minus 1.5. So we having this equation by considering column FBD AB, also by considering shear force at A and end moment, and taking moment about B, we have this equation. Now put here MAB and MBA values. MAB and MBA means these are the combination of moment due to the non-sway frame and sway frame, but in a sway frame consider C as a correction factor. So putting this value here, we have this equation. Okay, this we put this MAB and MBA value here in equation HA, then we have this final equation. Okay, in term of moment, that means sway and non-sway moment, and also in term of correction factor C. Okay, now consider FBD of a column CD. On column CD 10 kN per meter UDL is acting, and again let's consider HD horizontal force acting toward the right hand side, and anti-clockwise moment at end D and C, at end D MDC and at end C MCD. Now take moment about C. So moment about C, again the sign convention are anti-clockwise positive, clockwise negative. So HD into 2, distance is 2, rotate about C in anti-clockwise direction, therefore sign is positive. Then moment, both moment are we assume as anti-clockwise, so md plus mdc plus mcd. Now there is a 10 kilonewton force which is acting at the center and rotating clockwise direction about point c. So minus 10 into 2 into 1 is equal to 0. So we have hd is equal to minus in bracket mdc plus mcd divided by 2 plus 10. Now put here value of mdc and mcd. So we have this equation hd in term of moment due to the non-sway frame and moment due to the sway frame along with the correction factor. Now after the calculation of this hd, now let's consider whole frame. Okay, and consider the horizontal forces or horizontal uh, equilibrium condition for whole structure. So there is a HA which is acting here, and here is HD. So HA plus HD horizontal toward the right hand side positive, toward the left negative. So HA plus HD, and there is a 2 kilonewton point load acting toward the right hand side. So plus 2, and this UDL we have to acting toward the left hand side. So minus 10 into 2 is equal to 0. So finally we have equation HA plus HD is equal to 18. Now the above calculated equation in term of HA and HD put in this equation. So finally we have this equation in term of moment only. These moments are moment of again non-sway frame and moment of a sway frame considering the correction factor. We know the value of moment MAB, MBA, MBC, MCB, MCD and MDC for each member by doing non-sway moment analysis and sway moment analysis for the sway frame. So in the sway frame we do the two type of analysis. One is considering frame as a non-sway and then considering frame as a sway frame. So these are the two values, and these we call it as a M1AB and M2AB, and there is a correction factor C. Now putting these value here in this equation which we obtained by considering the FBD of a whole structure and by considering the shear force as a equilibrium condition. So summation of Fx is equal to 0, and putting the equation in that we having this equation. Now put this value here to get the value of C. So MAB is a 0.717 and MAB second is 11.10 into C. Now MBA first is minus 1.182 and MBA second is 12.18 into C. So likewise putting the value of all moment here in the equation, finally we have a value of a C. So C is equal to minus 0.171. Now put this value in the to get the corrected moment. So MAB is equal to first MAB plus second MAB into C. So our corrected moment MAB is equal to 0.717 minus correction is now this correction we have to apply minus 0.171 into 11.10 we have minus 1.181. Similarly corrected moment MBA is equal to first moment due to non-sway moment into plus correction factor into second moment by considering sway frame. We have this two value minus 1.182 minus 0.171 0.71 into, this is second value, 12.18 is equal to minus 3.265 kilonewton meter. Same way, let's find out for BC. This is our next one, BC. Adding these two, and here we have to apply value of correction. This value is minus 0.171 into minus 12.18, and this MBA 1.182, we have 3.265 kilonewton meter. The next consider MCB. First value is minus 3.231 minus correction 0.171 into minus 37.80, we have 3.233 kilonewton meter. Then find out for CD. So value of CD plus 3.231, then correction value minus 0.171 into this 37.80, we have minus 3.233. Same way, let's consider last one. Apply for sway moment correction factor. Do the addition of these two moments, we will get the MDC, corrected MDC, and it is minus 13.527 kilonewton meter. Okay, so now we having all moment, corrected moment. Now draw the bending moment diagram. These are the corrected moment. MAB is minus 1.181. So keep your pen close to the A. This one is moment MAB, and rotate about A joint in a clockwise sense. So rotate in a clockwise sense because moment is a minus. So after crossing the member, vertical member, the arrow coming toward the right, so your moment you have to show toward the right hand side of a member, 1.181. Now MBA is minus 3.265. Now keep pen close to B and rotate about B in a clockwise sense. So after crossing the member, arrow coming toward the left hand side, so show toward the left. So these are the location of your end moment. Then joined with the line, you will get end moment diagram. Okay, so these two value, end moment sign is negative, so when both end moment having the same sign, you see these values are opposite to the your column. This column is vertical, one value is just to the left hand side and second value is right hand side, so that means they are opposite to the column. Okay, so then you have to join with the line. Then draw the bending moment for the your point load 2 kilonewton, and how to find out WAB divided by L. W is 2 into 3 into 1 divided by 4, you will get 1.5 kilonewton, and that one is in a triangular fashion. This is in a triangular fashion, and portion which is not overlap, that you have to show with the hatch line. Okay, so this portion you have to show with the hatch line, and portion which is overlap, that you keep as it is. So this is portion which is not overlap. This is portion which is overlap, and this hatch show the portion which is not overlap. Now next round, draw for the beam BC. So for beam BC, the moment is 3.265. So keep your pen close to B and rotate in an anti-clockwise direction about the B. After one complete rotation, arrow coming up, so show this end moment up. Then for CB, again keep pen close to C over the member and rotate about the C in the positive sign. That means you have to rotate in anti-clockwise direction. So after cutting, arrow coming down, so show down. Then you have to join with the straight line. You will get the diagram for the end moment. Then draw the bending moment diagram for free bending moment diagram for point load 16. So WAB by L you will get 6. Now next is vertical column CD. Now the end moment are minus 3.233. That means you have to rotate in clockwise direction. Keep a pen close to C and rotate clockwise about C. Minus is there, so arrow coming toward the left hand side, so show toward the left end moment. Then keep pen close to the D. Minus sign is there, so you have to rotate about D in a clockwise direction. After one complete rotation, arrow coming toward the right, show the moment toward the right 13.527. Then join with the straight line, you will get end bending moment diagram. And for the UDL, free bending moment diagram is WL square by 8, it become 5, and you have to show in the form of parabola. Now the portion which is not overlap, that you have to hatch. So this portion is not overlap, so you have to hatch it. And this white indicate overlap between this parabola and triangular portion. Okay, so this is about your bending moment diagram. Thank you.